Hi and Assalamualaikum Dr. Haryati. I hope you and your family are in safe condition during this pandemic. My name is Muhammad Amir bin Hussein. Uh, right now I want to talk about the infographic assessment for course protein separation technique in biotechnology SMBT 4663 session 1. For this assignment, I have selected a journal which entitled Efficient Single-Step Chromatographic Purification of Recombinant Human Antithrombin rhAT from Saccharomyces cerevisiae that published in 2016. There I also put citation about the journal for your reference. So as we can see, this is what my infographics looks like. So now we go to the introduction. Okay, for the introduction part, firstly, I would like to explain about the recombinant human antithrombin (rhAT) itself. Antithrombin (AT) is a plasma glycoprotein with 432 amino acid and a member of serine protease inhibitor serpin family, which is an important physiological controller of various clotting proteases and including thrombin. So purification of rhAT from Saccharomyces cerevisiae have been carried out using two different approaches used as a cross flow filtration CFF and chromatography method to achieve high recovery yields and profile. In the first approach, the protein was concentrated and partially purified through CFF to achieve maximum recovery yield, purify of 87 and 19.4% respectively. In the second approach, purification involved a single-step chromatography with various types of ion exchange and size exclusion resins to analyze the maximum rhAT recovery yield and purify. In addition, the effect of various physiochemical parameters such as mobile phase, flow rate, sample volume, and volume concentration of rhAT purification were also investigated. Okay, now let's see the method performed in this journal for the purification of the protein. Okay, firstly, in the production of rhAT, the chemical and tools was used in a standard protocol according to the procedure. Large-scale production of rhAT in the Saccharomyces cerevisiae was performed in fed batch cultivation mode, with a medium volume. The fermentation also was carried out in the following condition: temperature 30 Celsius, pH with 7.1, and dissolved oxygen with 40%. The foaming was controlled with a silicon anti-foaming agent. After that, cell which be harvesting and lysis. The fermented broth was harvested and the pellet was collected by the centrifugation. The cells were washed with the buffer containing 0.05 MEDTA pH with 8 and 0.01 M3HCl with pH 7.6. The cells were lysed by sonication 20 kHz for 2-4 times interval using lysis buffer. After cell lysis, the procedure will continue with the concentration of the rhAT protein solution. The lysate was concentrated and simultaneously clarified using the CFF system with a loading volume of 500 ml. The filtration was accomplished using a stable pump speed at 3000 rpm. The concentration intensity of the rHT is distinguished by a concentration factor and retention factor. Next is purification process rhAT. The main objective of the purification process is not only the exclusion of the undesired contaminant, but also the purification of the target protein. Ion exchange chromatography (IEC) is certainly the most commonly used technique for the separation and purification of protein. polypeptides, including nucleic acid, polynucleotide, and other biomolecules. The explanation behind the accomplishment of IEC is determining power, broad prevalence, high capacity, and the effortlessness of the system. Size exclusion chromatography SEC is another purification process in which components are filtered according to their size and it's sometimes molecules mass. It is frequently used to purify the large of macromolecules such as protein in the. Okay, now let's talk about the result and discussion after the experiment was done. Okay, now we look at the result and discussion part. Okay, for the result and discussion, we talk about the effect of chromatographic resins of rhAT purification. We can see table 1 show the recovery yield and purity of rhAT for both ion exchange and size exclusion chromatography, which different resins for ion exchange resins was Q cephos, Subto Q, and CM cephros FF, while size exclusion resin Cephrical S 200, Cephidec G hundreds, and Superose 12. From the result, it can be seen that among various resins selected in both ion exchange and size exclusion chromatography, size exclusion chromatography with Superose 12 show maximum recovery yields and purity of 51 and 97% respectively instead of ion exchange show 48% and 97 of recovery yields and purity respectively on CM Cephros FF. The lower yields with ion exchange could be attributed to low permeability and capacities of resins for larger proteins such as antithrombin. Additionally, the hydrophobic character of the ions exchange resin will denature the protein. Next, we will see the effect of mobile phase of rhAT purification. The choice of mobile phase play critical roles in the purification protein because they are thought to be adapted to the buffer atmosphere during the elution. In the present works, a study has been performed on the four different mobile phase, trace, acetate, phosphate, and sulfate, which pH 7.2 using size exclusion chromatography which sucrose 12 and the recovery yields and the purity of the rhAT which the four different mobile phase buffer were shown in the table 2. From the experiment result, as we can see, the recovery yields 50, 52, 55, and 51% and purities 7.9% of rhAT were obtained with the respectively mobile phase buffers such as trace, acetate, and phosphate, and sulfur buffer. From the above result analysis, it was concluded that phosphate buffer has achieved a high recovery yields, 54%, with the 18.8% purity. The lowest recovery yields, 50%, was achieved with the trace buffer with 97 purity. However, acetate and sulfate are next to the phosphate, with recovery yields of 52 and 51% respectively. Next, I will explain about the effect of the flow rate on the rhAT purification. Flow rate should be considered as one of the most significant parameters during protein purification because in the size-based separation, it may influence the protein structure, biological activity, and recovery yields. Although using the lower sample flow rate result in longer run time, the increased resolution gives greater and confidence and optimum column efficiency. Furthermore, the effect of the sample volume of the rhAT purification samples injection volume can be influenced the protein purification and effect most on recovery yields. Therefore, in the present study, rival experiment were carried out on the rhAT purification with different samples volume as 1, 2, 3, 4, 5 ml. From the result analysis, it was concluded that the maximum recovery yield 60% and purified 98% with the sample volume of 2 ml were observed. This is attributed to the suitable volume of the sample that enter through the resin and increase the passage the passage of desired protein molecule. The lowest recovery yield of 55 and 56% were achieved with the 1 and 5 ml volumes, respectively. This is due to the broadening of the sample zone by increasing the sample volume and decrease the passage of the sample to the resin. Lastly, the effect of the protein concentration of rhAT purification. Here, I want to tell the sample concentration may also influence the chromatographic resolution and sensitivity. A study has been conducted on the different protein concentration ranging from 1 to 4 ml, which superose 12 metric to analyze the protein concentration effect on the recovery yields and purity of the rhAT. Okay, last but not least, we will talk about the conclusion for this journal. Okay, in the conclusion, what we can talk about is cell excretion chromatography is found to be an effective technique for rhAT purification compared to the IEC, ionic exchange chromatography. This is because show a maximum recovery yields 51% and purity 97% when compared to the ion exchange chromatography recovery yields only 48% and purity 97%. Further investigation on physiochemical chromatographic conditions such as flow rate, sample volume, and sample concentration will also prove their influence on recovery yields and purity of the rhAT. So I think that's all from me. Thank you for listening, Doctor. And I hope we all safe, survive, and in a good health condition during this pandemic and can undergo our routine activity like usual. Um, Thank you, Doctor.